In today's video, we're going to discuss PCR, which stands for polymerase chain reaction. And this video is more focused on the finer details of how it works. So I'm assuming that you guys already know the key players in a PCR reaction, like the Taq polymerase and the DNTPs and all the pieces that are necessary for this reaction. If you're unfamiliar with those terms, then in the description for this video, I'm going to leave a link to another video that will go over the bare bones and the basics of PCR. And so from this point on, what I'm going to talk about, if you don't know the bare bones or the basics, then this video is going to be a little too advanced. Because I want to show you like every step of the way on what's happening and how it's working. So the purpose, there's many purposes of PCR, but the one that I want to focus on is a technique in which we want to amplify a particular gene. We want to make millions upon millions of copies of a particular gene. And this particular gene of interest would be, in this example, found in a plasmid. So that little pink area right there, that's the gene of interest. And that gene is going to encode for a particular protein. And so there's certain techniques or certain scenarios in which I need to replicate the DNA, not the entire plasmid of DNA, just this little segment right here. And so we're going to zoom in on that section right there and look at it like this. So we're going to have, and we're going to read it in the 5' direction here. And we're going to have GGG. So that GGG is this part right here. And it's going to extend all the way around the plasmid. But I'm not going to write all the nucleotides around this plasmid. So this GGG right here is going to represent just a little bit right there. And then the pink part right here is going to, I'm just going to make it up here. We'll just say it's CAT, CAT. And then I'm putting the dots because this is a rather large gene, CAT and CAT. Okay. And so now we're here with this, these first two cats are right about there. And then these last two is right here. And so now we need to put in the little bit right there. And that's going to be CCC. And that would be the 3' end. Now we have the complementary strand right here. That's anti-parallel that we need to write. So there's 3'. So CCC, that would be right here. And then we have GTA, dot GTA, like that. And then this little bit right there, which would be GGG, like so. Okay, so there's that little segment. That's the gene of interest, and this is what we want to copy. Make millions and millions of copies of just this, nothing of the green. Now, before we get into how we do that, let's just review some terms so that we're all saying the same thing. So when we look at this DNA sequence, we have on the top strand right here, this top strand is called the coding strand. Called the coding strand. It also has been referred to as the sense strand. And it's also can be referred to as the non-template. strand. And then here on the bottom, okay, this bottom strand right here, that will be everything opposite of what we've seen on top. Okay, so that's going to be the non-coding strand, the nonsense strand, or no, antisense, sorry. The antisense strand and the template strand. So those are the 6 words that will be used interchangeably in conversation, referring to those 2 strands right there. Okay. Now, what we're going to now do is start the process now of the PCR. And the first step in the PCR is that we have to denature the DNA. So we have to heat it up so that the double-stranded DNA here breaks apart and becomes single-stranded. And so let's redraw this DNA separated so we can figure out how to design the primers in order to do the PCR reaction. Now, when we design our primers, we're going to have what's called a forward primer and a reverse primer. And so when we take a look at our single-stranded DNA here, what we're going to do is come here to the template strand right here, and we are going to create a primer that aligns with this sequence right here. And the primers are typically 15 to like 30 nucleotides long. That's how you design them. Because remember, this gene right here is really, really long. Okay, it's rather large. And so your primer is going to be around 15 to 30 nucleotides. But for space on this board, I'm just going to design a primer that's 3 nucleotides long. Please note that that's not the real way that you design primers, because they need to be longer than that. But just for space purposes, we will just design a primer that's 3 nucleotides long. So we come here to the template strand, and on this side right here, what's going to pair up with these nucleotides right here? G pairs with C, T pairs with A, and A pairs with T. And so that primer that I've just designed right there is in the 5' to the 3' direction. Okay? And so that's going to pair up with this first 3 nucleotides right here. And so when the DNA polymerase attaches here, how is this strand going to be synthesized? It's going to be synthesized in the 5' to the 3' direction. So we are synthesizing the template, right? Or we're using this template right here to synthesize the coding strand in the 5' to the 3' direction. Now I called this new one in blue the coding strand because what are we synthesizing? The exact match above here. And so this is called the coding strand. So what we're doing is using the template strand to synthesize the coding strand. And so that right there is the forward, we'll put it right here. That is the forward primer. So in essence, you could look at it in these 2 ways. Okay? So what is the forward primer going to do? It's going to anneal to the template strand. And then it is going to synthesize the coding strand. That is the definition of the forward primer. Now the reverse primer, we're going to start on this end, right here. And the complementary, or the base pair here, C would have to be with G, A with T, T with A. And that primer is annealing in that direction, the 5' to the 3'. And so that primer is still going to be synthesized in the 5' to the 3' direction. So it's going in that direction. And so what we now have, okay, is that this is the reverse primer. And so what can we say, what defines a reverse primer? Well, the reverse primer is going to anneal to the coding strand, okay, and it's going to synthesize the template strand. Okay, so those are the definitions of the reverse primer and the forward primer. So after this first cycle of PCR, what we've done is we have gone from a circular plasmid, okay, to something that looks relatively like this. Just linear DNA, and we're going to have our gene of interest somewhere in there. So after the first round, we have just gone from the plasmid, which is circular, to a linear form of DNA. Now I want to take some time now and show you what happens after the first round, the second round, third round, maybe the fourth round. And I want to show you what DNA molecules we are going to get after each step. So what I want to do now is kind of like finish this piece right here and draw what we get. Okay? So I'm going to erase this top part here. But make sure as you're watching this video that you've written down this sequence right here, and so you can follow along, because I don't have enough board space to have everything up all at once. So we're going to go through this step by step. Make sure you take good notes, because we're going to have to always refer back to your notes to fully understand this. So I'm going to do my best to keep as much of the information on here as possible. So what I'm going to do now is I'm just going to try to enumerate these strands so we can keep track of them. So I'm going to call this number 1 strand, and this is number 2. Okay? Now when we do the PCR reaction, and we're going to do the PCR reaction on this number 1 strand, after the PCR, what does your DNA molecule look like? So we have this top, the coding strand right here. And so let's write that right here. So we have a GG like this. We have the CAT. And then we have the CCC. So this primer, the GTA, annealed to just the CAT on this end right here. Okay? And so what's going to happen is that this 3' strand that we're going to generate is going to start here. So that means it only has DNA here, so not green. So GTA, and then it goes GTA, ... And then it continues to polymerize and synthesize the DNA, so we have the rest of this chunk. So CCC. So now what we've done is this number 1 strand has now made another DNA molecule. Okay? So we could say, hey, this we'll call that DNA molecule 3. Or I'm just referring to this double-stranded DNA as 3. Okay? But then we would have the second strand of the original DNA. And what's going to happen here? The primer started right here. So on the 5' end, what do we have? We have CAT. So we don't have anything in green, so we just have CAT, CAT, dot CAT. But as it's synthesized in the forward direction, it's going to copy all of the green stuff. So that would have to be CCC 3'. But then we look at this number 2 strand here. We still have the green right here, so that's going to come along for the ride. So that would be CCC, and then the template strand right here, so GTA. Okay. And that's going to have to follow with the GGG 5'. So now we've just made, so we went from the plasmid after the first cycle, we've gone to now 2 linear molecules. Now if you go back to the original, which is shown right here, do you see how we have green and green on both sides? And then green and green on both sides. But after the first round of PCR, we're going to have a new DNA molecule where we're missing some of that plasmid. And then on this molecule here, we're missing the plasmid right there. Okay? So now, in the next round, what we're going to do is we're going to take molecule 3, denature it, anneal the primers, and do this process right here all over again. But now it's this molecule number 3 and molecule 4 we have to keep track of. So now we're going to expand this out. Now probably the best way, well, let's see. So what I'm going to do is I'm going to take this strand, or this double-stranded DNA, and I'm going to put it down here, denatured, so we can make the next molecule. Okay, now I have taken molecule 3, which is these 2 strands right here. This is molecule 3 that's been denatured. Now we're going to take the forward primer and to anneal that to the template strand. So that would have to be CAT, and that's the 5' to the 3' direction, and that's going to synthesize in that direction. So there's our forward primer, and then our reverse primer, GTA, that's 5' to 3'. It's going to synthesize in that direction. Okay. Now what's going to happen now, what is the new molecule going to become? Because now molecule 3 is now going to be turned into this new double-stranded DNA and then this new double-stranded DNA. So what I want to do is just call this guy right here, that's going to be number 5. That's the 5th molecule, and this one's going to be number 6. So when we clean this up here, after the PCR reaction has been done, what is the new molecule going to look like? Okay? So let's take a look here. So I'm going to now take this primer here and fill in what it's going to turn into. So that, let's keep it consistent. This primer now turns into the gene of interest, GTA, GTA, TA, and then it synthesized, that's G, so C, C, C. There's our 3 prime, there's our 5 prime. Okay? So that's what molecule 5 looks like. And molecule 5 came from the top strand or the coding strand of molecule 3. Now molecule 6 is also going to come from molecule 3, but from the template strand. And so if we finish out this polymerization right here, our new molecule is now going to look like this. So CAT dot CAT CAT and no green. So molecule 5, you see that we have plasmid, or we'll call it the gene that we don't want, all the nucleotides in the plasmid. Green, green, green. But now this piece right here, look, we're getting rid of the green, but we still have that piece right there. Okay, so now we're going to do this all over again now with molecule 4. So to save on space right here, what I'm going to do is take this template strand on molecule 4 and let's denature it and just make it come down here. So what did we have here? We had the 3, let's bring it down here. So what was molecule 4? It had the CCC GTA and then it had GGG. Okay, so I kind of denatured it a little bit more there. So let's take, for molecule 4, which has now been denatured, we add the forward primer. That's going to be CAT. That's the 5 prime, the 3 prime. That's going to synthesize all of that. And then if we put on the reverse primer, GTA. That's 5 prime, 3 prime. It's going to synthesize in that direction, like so. So molecule 4 now is going to give us 2 molecules of DNA, this guy and this guy. So if we clean up that sequence now, let's do the coding strand first. What are we going to generate now? That's going to be and so that will be our 5 prime. That's our 3 prime end. Like that. So now this new molecule right here, now we're getting kind of crazy here. This molecule right there came from the coding strand of molecule 4. But now this is its own new molecule. And since we'll call that molecule 7. And in molecule 7, you see how we've got rid of the green here, but we still have one little chunk there. Now this one right here came from molecule 4, but using the template strand. So if we make this molecule, so let's see the forward primer annealed here. So that's going to be CAT, AT, CCC 3 prime. So this would be our 5 prime end right there. Now we have the 8th molecule right here. There, that's number 8. And number 8 came from molecule 4 using the template strand. So now we have 8 molecules, okay? So now when you do the next round of PCR, you're going to have molecule 3, 4, 5, 6, 7, and 8, all going to be denatured. Primer's going to add, and you do it over and over again. But there's going to be, I'm going to just focus on maybe 1 or 2 of these molecules here, so you can see that we are going to eventually get to some DNA that just has pink. It has nothing flanking it in green. Okay? So that's what we're going to do next, is we're going to pick one or two of these molecules here and say which one, once we do another round of PCR, will give us just a double-stranded DNA with nothing flanking it in green. So what I'm going to do is I'm going to focus on molecule 6. And I'm going to take that, denature it, and then we'll do the PCR on that and see what happens. So we could do the process all over again for molecule 5, 8, 7, and so forth. Okay? I'm not going to go through each one. I'm just going to look at molecule 6. Okay, so I've taken molecule 6, denatured it. So this is molecule 6 right here. So now we take our forward primer. So that would be CAT. There's our 5 prime, 3 prime end of the primer. That's going to synthesize in that direction. Our reverse primer, GTA, 5 prime, 3 prime direction, synthesize in that way. So if we take the coding strand right here, and then we do the DNA polymerase, what are we going to generate? We are going to generate a new molecule that looks exactly like this, GTA. Boom, so that coding strand from molecule 6 has now been turned into a molecule that we could call number, we were at 8, so that could be molecule 9. You can see that molecule 9 is just the gene of interest. We got rid of all the green. But molecule 6 template strand, shown here, is going to turn into a second molecule of DNA. It will turn into molecule 10. But what does it have going against it right now? Let's see here. So CAT, dot, dot, dot. All right. And so that would be our 3 prime end right there, 5 prime end. But you can see it still has a little bit of green. So this new molecule right here, we'll call that number 10, but it still has a little bit of green there. But now, hopefully you can see how this reaction is exponential, because now you have a molecule 10, which has a coding strand with no green attached to it on either end. So when molecule 2 goes through the process, or molecule 10 goes through the process again, you're going to get another molecule of DNA that just contains your gene. And then obviously these two strands right here in molecule 9 are going to give you just the pure gene. And it's going to go over and over and over and over again. And if we come back to what was on the board, we had I chose to do molecule 6. But was there another molecule that had at least one of the strands with no green attached to it? And I think there was, and molecule 8. Molecule 8 for sure had a strand with only the gene of interest. Nope, not molecule 8. It would have to have been molecule 7. But the idea is that once you get molecules with at least one of the strands with no green or DNA that you don't want that's attached, then that's just going to, and within 25 to 30 cycles of this process, you're going to get millions upon millions of copies. Well, let's just say millions of copies, okay? Lots and lots. Okay? So that is PCR, and that's how you're going to just replicate a lot or make many copies of your DNA. So I hope you find that helpful. If you have any questions or concerns, please let me know.